Hey, what's up? It's Jake from Nimbus DevOps, and today we're going to be going over AWS Cloud Networking, which will be a primer on VPC networking, and I'm going to target this for a non-networking person. So here's a scenario. You've just accepted a position at a new tech company, and they have asked you to establish a simple custom network, not the default, in the AWS Cloud. You've been given a day to complete this task. Afterward, you will attend a meeting to demo the new network and answer any questions that the system administrators and network engineers may have. So this is a common scenario when starting a new job, when you're trying to build something either from scratch or they want to move something or whatever. And network is something that people struggle with a little bit. So I figure I would throw something out there that explains everything from scratch. So instead of just creating a VPC, you kind of know what's going on. And as soon as you get to the end of this, we'll do a little demo. So let's talk about the network. So what is a VPC? You may have heard that before. Well, it stands for Virtual Private Cloud. And you can think of it as sort of a virtual data center, just like you would have like an on-prem data center, except this time it would be hosted in AWS. Everything you launch is inside of a VPC, but the main difference between traditional network and a virtual network is that you can scale out the infrastructure, whereas in on-prem environment, you're limited to the infrastructure you have in the data center. So if you take a look at this image on the right, you can see these series of boxes. So the outside box would be AWS, and your users, or you, the user, will be on the outside of AWS. So AWS is made up of regions and availability zones, and you can create a VPC in the region, and you can create subnets in the availability zones, and all this is accessed through a couple different little services, little things inside the VPC service, and we'll go over that here. So um, there are multiple regions in AWS, and we'll get a little bit more into that, but a VPC lives inside of a region. And in that VPC, if you want to get to it, you go through an internet gateway. So you enter through the gateway and you hit a route table, and it says, I'm trying to go to this IP address. And then it'll say, oh, I know where that's at. But before it goes there, it'll go through a network access control list, or ACL. And once it deems that you have permission to indeed go there, it will route you via the route table from the internet gateway to whatever resource you're accessing. So if that's in this guy, maybe it's a public web server or something, it'll go, oh, that lives in this availability zone, and it'll just route you here. And the other way around, if you're doing updates on a EC2 instance or something, the public subnet will go out of the internet gateway to get out to the internet to download whatever it needs to download. So that's just kind of like a brief overview to get started. So the other thing I wanted to talk about really quick is DNS. So how exactly does DNS work? So in the previous slide, you have a user going through the internet gateway. Well, that user might be going to like yourwebsite.com, right? And the instance or server, online server, we call them instances, doesn't know that it's online.com. It knows it has an IP address, and there's some network stuff that happens in DNS, and you can either do that with something called DHCP or with Route 53 that translates the name yourwebsite.com into an IP address. So in this case, when you create a VPC, it creates a bunch of stuff, and it looks like this. And you might not know what these things are. Things like DHCP option sets and domain name server, things like that. And even NTP or NetBIOS and all that stuff. So I won't go over NTP too much or NetBIOS, but the other stuff. So how does it actually work? You can think of it like a phone book. So it's going to look up your name in the phone book, just like we used to do back in the day. And it's going to go, oh, your name is Jake and your phone number is this, and then you can call me. Well, it does the same thing, but with a domain name like yourwebsite.com, and then it finds the IP address and then translates the text of your domain name into IP address numbers. So if you try to ping google.com, see what happens, and you'll see that it's trying to ping an IP address. Now that's not the actual IP of google.com. It's more of a translated IP address of google.com, and they have several because, as you can imagine, a lot of people use it. But you'll get the idea. So the next thing I wanted to talk about was Cider notation and subnetting. So the thing about, before I do that, I talked about regions and availability zones. I'm assuming you probably know what those are, because there's a million videos on the internet about it. And really where it gets down into it is, I think most people understand the concept of a region as a geographic location, and availability zone is like a physical place inside there. And there are multiple availability zones in a region, and there's multiple regions in the cloud. So where it really breaks down is when people start looking at addressing, subnetting, Cider notation, stuff like that. So that's what I'm going to spend some time on here. So what is Cider notation and subnetting? Well, Cider stands for classless interdomain routing, which is not super important for you to know what it stands for. You should know, but it's more important is it's a method for allocating IP addresses for IP routing. So a Cider block, as we call it, is just a group of IP addresses. So one thing you'll see when you create stuff in the AWS Management Console is things like a VPC having an IP address with a slash and then another number. And this would be a Cider block. So 10.0.0.0/16. And that's all the IP addresses you can use. You may not really understand what that means, but it's what the document or YouTube video you're watching says to do, so you just do it, right? And then you have subnet, maybe a subnet A and a subnet B, and they've also got an IP address and some slash number after it, and it might not make a whole lot of sense what's going on here. So let's break this down. What are these slashes, /16, /24? Well, it's a way of representing IP addresses. So what the technical name for it is variable length subnet masking. And if you're going to remember anything for AWS, the best thing to do is to just memorize the fact that /24 equals 256. Okay, and that's a good starting point, and you'll see why here in a minute. It's one of the most commonly used numbers, /24. So where exactly does this come from? Well, here's a breakdown of everything up to /16. So we said memorize /24 equals 256. So go ahead, notice there's a pattern. As the slash notation decreases, the number of the IP addresses doubles. So we start at /32, and that's one IP address. And if you go down to /31, it doubles, and you get two IP addresses. /34, 29, 8, 28, 16, and so on and so forth. And you can see as it goes down, they just keep doubling and doubling until you get to /16, which is 65,536 IP addresses. So who has the time and brain space to actually remember all this? Well, it's not that hard, actually. If you remember that this is 256 and you need a smaller one, you can just increase the number in this Cider notation of your /26, /27, whatever, and go, well, half of 256 is 128, half of 128 is 64, and just keep going there, and you can kind of use your fingers and toes and figure out, what number you need. And then you can also go the other direction. Most of the time, you're just going to see /16, /24, and /32. In some cases, you'll also see /25s, but I'll get into that. And the way that the cloud networking works, there's not a whole lot of reason to use a lot of these other things. So you don't see them as often, but they're totally fair game. You can use them if you want to. So why does it start at 32? Why is /32 equal 1? Well, let's break this down. Every IP address has these four numbers separated by dots, right? So in this case, like 10.12.25.16. And I just gave this a /16. But each one of these spaces before a period is called an octet. Okay, so your first octet would be 10, your second octet would be 12, your third would be 25, and your fourth would be 16. And each octet has a maximum of 256, but it starts at 0, so the way you'll see it is 0 through 255, because 0 counts as your first address. So there's theoretically, you could have 255 numbers in the first octet, 255 in the second, third, fourth, and then all these would be 255. That would be the absolute highest number you could possibly get to. And the lowest is obviously 0.0.0.0. So how does that help us figure out what 32 is? Well, you got to go a little another step further. So what is an octet exactly? Well, if you remember from school maybe, what does oct mean? Yeah, octopus, octagon. Well, it means 8, right? So if you look at this address, 10.12.225.16, and we're just going to take the fourth octet, for example. Each octet has 8 bits in it. So if you convert 16 to binary, right, we're getting 16 from this fourth octet. If we convert that to binary, you get this number. And you know that because binary would go 1s, 10s, 4s, 8s, 16s. So we have 0 128s, 0 64s, 0 32s, 116, 0 8s, 0 4s, 0 2s, 0 1s. So this would be the binary string using 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. This would be the binary representation of the decimal number 16. And it's important to note that we're using 8 bits, right? Each place in binary is a bit. So why does that matter? Well, each octet has 8 bits. There are 4 octets, therefore 4 times 8 is 32. And that's why /32 is the first number that we start with. So if you're ever wondering that, that's how that works. And all of this kind of relates also to subnet masking. So imagine taking this IP address 10.12.25.0/24. So in this case, /24, I told you, is 256 addresses, right? So this would cover 10.12.25.0, 10.12.25.1, all the way up to 10.12.25.255. So it basically used all 256 options in the fourth octet. So imagine if you covered up the first 3 numbers, right? You just covered this up with a piece of paper or something. So like I said, /24 means you can use the first 256 IP addresses, which doesn't mean first octet. It means it starts over here, and the more you use, the farther over to the left it goes. So the first IP addresses occur in the fourth octet. So if you cover up everything but the last 256, and I cover them up with 255s, right? It would look like 255.255.255.0. This says you can't use this, you can't use this, you can't use this, but you can use whatever you want over here. So this would basically be kind of like saying /24. So if you had 10.25. or 12.25.0 on your like Linux server, or you're looking in your Windows network settings, and you'll see, oh, I have an IP address, and then you'll see a subnet mask. Well, you can tell from the subnet mask how large the network is that you're on, just by knowing what it's covering up. So in this case, if I said a /24 is 256, a /25 would be 128 addresses. So the subnet mask would look like you can't use this or this or this, but you can't use half of this, so you can use the other half. And a /16 would be you can't use the first 2, but you can use any address in the second or in the third octet or in the fourth octet. So that's basically subnet masking. So then you get subnetting. And subnetting is when you break up a Cider block into smaller blocks. So in our example, we gave the VPC 10.0.0.0/16. And that's 65,536 IP addresses. And let's say I want to break that into 2 public subnets and 2 private subnets. So I could have 10.0.0.0/24, which means I can use all of this octet, 256 options, and then I could make this another subnet, and say 10.0.1.0, and the /24 says I can use all 256 of these. And the difference between these two is if this was subnet A, you know it starts with 10.0.0, and then whatever else after it, it's just an instance that lives in subnet A. Subnet B would start with 10.0.1, so anything with a 1 would be this subnet. And if I did a couple of private ones, I could do 10.0.2 or 10.0.3. And I'm just saying, hey, I have 4 different chunks that I broke out of this big Cider block to make smaller Cider blocks. And each one of these is a sub-network of the primary network. So the subnetting comes from creating a sub-network Cider block out of the main network Cider block. So here's what that would look like if you broke it down. So if I just did the 2 subnets, right, a /24 would be 256 addresses. And let's say I want to break it into 2 subnets that each have 128 addresses. So I could use 10.0.0.0/25, and that would give me the first 128, which would be 10.0.0.0, 10.0.0.1, all the way to 10.0.0.127. Remember, it uses 0, so it only goes up to 127. And then if I wanted to use the second half of this Cider block, I would say subnet B is 10.0.0.128, because that's where we left off, right? And then I would do a /25, so it's going to be 128 addresses starting with number 128. So 10.0.0.128, 10.0.0.129, all the way to 10.0.0.255. It's worth noting that some of these are reserved. I won't go over all of that, but generally speaking, don't use like the first like 5 IP addresses, 4 IP addresses, or the last IP address. Those are reserved for some things that happen internally. I don't need to really get into that right now. But when you're subnetting in AWS and you create these subnets, you can create them just like this. But generally speaking, what you want to do is make them easy. So you might have like 10.0. Let's go back here. 10.0.1, 0. This is like all of my web servers. 10.0.1 is going to be all of my databases. 10.0.2 is all my BI tools or something like that. And you can give it some kind of logic where you can look at the IP address and know what it is. But when you get to the last octet, I usually don't start until like 10, right? So 10.0.1.10 might be the first IP address that I use, just so I can go, okay, 10 through 19 are this, 20 through 29 or this or whatever. But honestly, you probably won't even get into that because the way that cloud provisioning works with the resources, it's going to dynamically pick all this stuff anyways. And in a traditional network, you would organize a lot of this, but in the cloud network, it won't pick it won't pick IP addresses it's not supposed to use. It just does everything by itself. So anyways, let's go ahead and do a demo, and I'll show you really quick what all of this is. Okay, so here I'm in the AWS Management Console, and I just searched for VPC and click on VPC, and I'm in the nice little VPC console. And I want to go look at my VPCs, and when you make an AWS account, and you pick a region, right? So we're in right now Northern Virginia, which is the region US East 1. And I have a default VPC, and that's so you can just start building stuff and going and doing all the things, but you really shouldn't use the default VPC. So we want to make a new one. So I just click Create VPC, and I'll give it a little name. And then I'm going to leave Cider manual input, so I can just tell it what Cider block I want to use. It is possible to do IPAM allocated stuff, which is new, but we're not using IPAM, so I'm not going to do that. So let's do what we did in our little demo, 10.0.0/16. So this would mean I have 65,536 IP addresses that all start at 10.0.0.0 and just go up from there. IPv6, we're not going to do any of that. Tenancy. Okay, so you have 2 options here, default and dedicated. So what this means is, do you want default tenancy where you share underlying hardware with other people that use AWS and allow AWS to manage the scaling and the replacement and the updates and all that other stuff? Or do you want to do dedicated where they still manage all that stuff, but it's just for you? There's a significant price difference, and most people just use default. Dedicated is really only considered when you're starting to look at certain security, compliance, regulatory, or bring your own license type situations. So we're going to leave this as default, and I'm going to leave this tag with the name demo, which came from here, and I'm going to create this VPC. So you'll see it created a whole bunch of stuff. And this is what I was showing in the previous slides, which was, okay, so now I have a VPC. It's got default tenancy. It's not the default VPC, right? It's available already. What is this DHCP option set? Well, a DHCP option set is basically just a set of rules that tell IP traffic where to go and what your DNS server is. So you can see here, it's going to use the internal EC2 network domain name, and it's going to use the Amazon provider DNS. So the DNS, when it resolves, is just using Amazon's DNS, and you don't have to have a DNS server. You can totally create an option set and have a different domain and have different DNS if you have your own DNS servers on-prem or somewhere else. Whatever you want to do. You can also, if you host your own NTP, because time synchronization is important, and you have your own NTP servers or very specific MTP servers, you can designate those here. And if you're running Windows, you can also use NetBIOS for all kinds of different things for discovery and NetBIOS type stuffs. So it's going to create that automatically. You don't even need to think about this, actually. Most people don't ever even touch this. We got our Cider block here, and then I've got DNS host names is disabled, resolution is disabled, and then it creates a main route table, and this main route table is attached automatically, and it has a route that just allows any place inside of the network that tries to reach any other place inside of the network. It's locally routed in here, and it's allowed to communicate. So you don't need to add anything for one server to talk to another, so long as they're in the same. Well, we'll get to that. Just a lot of caveats to that. Anyways, and then we've got a main network ACL, which is your access control list. It says this is who can come in, this is who can't come in. And if we take a look at this, you can see my inbound rules are saying allow all traffic, and then a rule that says and deny everything else. So in this case, it's never going to get to the deny because it's saying this is the priority rule and just allow literally everything. And then for outbound, it's the same. Allow literally everything. So once you create a subnet, you have to give it a route table so traffic in the subnet knows where to go. Like, how do I get to the internet? Where's my internet gateway? How do I get out of the AWS cloud? I want to go download cat photos or whatever. So we'll have to associate those later. So but anyways, that is by default what is created when you make a VPC. So the next thing we want to do is go, okay, we have a VPC, but I want to get in and out of here. So we want to make an internet gateway. So we can see here we have a default gateway. So we're going to go ahead and create one. So I'm going to call this demo IGW for internet gateway and create it. And we can see it's created here already, but it's detached, right? So now what we want to do is attach it to our VPC. So we come here, I find the new VPC, attach, and then the state changes and it is now attached. So now my VPC knows what internet gateway to use when traffic's coming in or out, which is great. But how does it know where it lives? Or if you ask to go to the internet gateway and you're an EC2 instance, how do you know to get there? Well, you have to have a route table, which we have here, that says, hey, if you're trying to go to the internet, use the internet gateway. So I'll show you how to do that. You edit your route. We're going to add a route and say, hey, if you're trying to go anywhere on the internet, so 0.0.0/0, that means literally anywhere, use the internet gateway. And it'll show the internet gateway that we just created. And then we hit save. And we'll be able to see here the status as soon as it updates. Let me just refresh the page. Bloop. Did I not save it? I don't think I saved it. 0, internet gateway. There you are. Yeah, save changes. There it is. Okay. So there we go. My internal network is allowed to talk to the rest of my internal network, and anywhere else trying to go, it needs, like anywhere on the internet or anywhere, it needs to go through the internet gateway. Sweet. So now what do we do? Well, now you probably want to build some stuff, right? So you need some subnets. So by default, you have all these default subnets. So what we're going to do is we're going to create our own default subnets. So we're going to go create a default subnet, and we're going to create them inside our new VPC. And here's the Cider blocks, and we're using a /16. And when you're starting to give these subnets addresses, this is where you need to understand Cider notation and how all this works. So I could go demo dash subnet A. Maybe I'll go US East 1A. Just going to copy this. Availability zone, I'm going to put this in availability zone A, for example. And then I'm going to give this 10.0.0.0/24. We're going to give them all /24 addresses, which means I can't use this in the next one. So I'm going to go ahead and add another one, and I'm going to name this demo subnet US East 1B. We'll put that in availability zone B maybe. It doesn't really matter. You can put no preference. This is just a very specific way of doing it. And I could do 10, watch what happens, 10.0.0/24. If I type this, you're gonna get an error when it tries to create it. And it's be like, hey, you already used this once. So I'm gonna change this to a 1. And then we'll do a third one for C in availability zone C, 10.0.2.0/24. We'll add another one for D. Maybe make this D 10.0.3.0/24. Add another one. Let's add E, availability zone E, 10.0.4.0/24. And then add the last one, our sixth subnet, which would be F, availability zone F, 10.0.5.0/24, and create subnet. 1, 2, 3, 4, 5, 6. So now you can see I have 6 subnets, A, B, C, D, E, F, and they all are up, and we can see the site addresses and how many are available. So you see there's 256 addresses in the /24, but there's only 251 available. So it's going to reserve the first 4 and the last 1. Okay, so that's good to know. So you can't use .1, 2, 3, 4 or 0, 1, 2, 3 or .255. So there you go. So now we have subnets, but our subnets don't have a route table, right? It just says I can see this. So now I can see, oh, it has 2 routes. Well, it's like an implicit connection to the route table or association. So let's go take a look here. So if I see subnet associations, there's explicit subnet associations, and then subnets without explicit associations, which I call an implicit association. And you read it here. The following subnets have not been explicitly associated with any route tables and therefore are associated with the main route table. So when you create the VPC and it creates that main route table, the reason it's called a main route table is if nothing else gets assigned, you can have multiple route tables, but if you build something and it doesn't have a route table associated to it, then it's going to use the main route table. It'll just default to that, unless you explicitly associate the subnet to a route table, which is exactly what I'm going to do. So I'm going to edit subnet associations here. I'm just going to check all these and say save associations. And now my subnets all have an explicit home. This is their home. This is your route table. Okay, so now what you could do is you should be able to, from here, you should be able to explain what a VPC is, how network traffic gets in and out of the VPC. You should be able to describe a region, an availability zone, what a Cider block is, what the slash notation is in the Cider block, what DHCP does, what's the DHCP option set, the difference between default and dedicated VPC with the tendency, what a route table does, what DNS does, all this at a fairly high level. Believe it or not, this is still kind of a high level. What is a network ACL, and why does a VPC have a main network ACL? What does it mean when a route table has a target local, right? Because I said it was internal. And what does it mean to enable auto-assign public IPv4 addresses? So the other thing you're going to see in here is you'll have in your subnet, like let's say I look at, these are defaults, I want the demo. Yeah. If I look at the demo, you got a subnet ID, how many are available, my network border group, it's not a default subnet, all these options, right? But then there's this auto-assign public IPv4 address, and it says no. So if I wanted to, let's say I wanted to make A, B, and C as a default, my public subnets, and D, E, F, my private subnets. So what I could do is I could say, okay, so for subnet A, I want this turned on. And that means that anytime you create an EC2 instance in here, it's going to automatically assign a public IP address to it and a private IP address. So let's go ahead and edit our subnet settings for subnet A, right? And I'm just going to check auto assign IPv4 public. You can also do this resource-based name. If you put the host name of the EC2 in this subnet, this optional DNS query can use. It basically enables an A record. We're not going to get into that. Don't even worry about it. Just enable auto IP and you'll be fine. Auto assign IP, sorry. So I'm going to hit save. So this just kind of became like the public one, right? So I'm actually going to, let me just do this. So I'll stop. Search this by demo. So we're going to rename this, and I'm just going to name this public A. Okay. So now I know this has a public. So when I'm making stuff, I can go, oh, if it's private, I don't want to put anything in there. And same thing, you'll be like, why can't I connect to this public web server? And you'll be like, oh, well, it's because I put it in a private subnet. It doesn't have an IP address. So now I have public A, public B, public C. And then you could go ahead and make a private A, a private D, a private E, and a private F. It's worth noting that not every availability zone, I'm sorry, not every region has 6 availability zones. Some have 3, some have 4, some have 6. So you just need to check your region if you're trying to figure out how many subnets to create. You can kind of go ahead and look that up. Now, I personally just don't usually assign specific availability zones. So if I was going to do that, like you see how this one has, well, you can't even edit it here, but when you're creating it, you can say, oh, I want this to be in US East 1A. I just let it pick whatever. But if you want to be super organized, which is a way better way of doing things, you can do it this way, and things will make a little bit more sense to people who are looking at it that weren't the ones that built it. So they'll be like, oh, public A, that makes sense. It's public. It lives in availability zone A. And you could do public A, public B, public C. You could do private A, private B, private C, and you could do whatever you want. But anyways, that's kind of how I just organized this quick little demo thing. So if you went back to your meeting tomorrow in this scenario, you should be able to explain all the different parts of the VPC. Should you have any questions, and if anybody looks at anything on the screen while you're doing the demo and goes, well, why does it say there's 251 addresses? Or what's the route table? What is this network ACL? Why does it say auto assign yes? What does DNS do? Like all this other stuff. Or you're in your VPC and people start asking questions about like what's a DHCP option set, stuff like that. So anyways, that's your little primer into cloud networking. I hope that was helpful. And next thing I'll go over is how to launch a web server in here using Nginx, and we're going to start walking through using this to really understand how it works.